Today, we're going to pull back the curtain on a huge concept that pretty much runs our digital world, object-oriented programming, or OOP. Now that might sound super technical, but it's really built on one simple, elegant idea. What if our code could work a little more like our brains do by modeling the real world all around us? Let's get into it.
So let's start with a kind of weird question. What on earth does a motorcycle have in common with the apps on your phone? I mean, one is a physical thing you can actually ride. The other is, well, it's just code, right? They seem like they're from totally different universes. But believe it or not, there's a really important idea that connects them. And the answer is actually pretty simple. They can both be thought of as objects. And that's it. That's the core idea. The whole point of object-oriented programming is to take things from the real world, whether it's a car, a person, or even a bank account, and represent them as digital objects inside our code. And that one simple shift in thinking, it literally changed everything about how we build software.
Okay, so to really get how this all works, we need to start with the two most basic building blocks. You can think of them as the bricks and the architectural plans that we're going to use to build our entire digital world.
First up, we have the object itself. In the world of OOP, an object is really just a thing, anything. And everything has two parts: a state, which is basically what it is, its properties and characteristics, and a behavior, which is what it can do, the actions it can perform. And this can be a real-world thing like a motorcycle, or something more abstract, like your user profile on a website.
All right, let's make this super clear with a simple example. A dog. Its state would be things like its color, its name, its breed. And its behavior, well, that's stuff like wagging its tail, barking, or eating. See? It's just a thing with a bunch of descriptions and a list of actions it can do. Simple, right?
But you might be wondering, where do these objects even come from? Well, they're created from something called a class. Now, this is important. A class is not the object itself. The class is the blueprint. It's the master plan that says, hey, any object of this type is going to have these properties and will be able to do these actions. It's the idea of the thing, not the actual thing.
So let's go back to our dog example. The class is the general concept of a dog. It has 4 legs, fur, it barks, dog stuff. But your actual pet, Fido, who's a brown Labrador that loves to play fetch, that is the object. He's the real, living, breathing instance that was created based on that dog blueprint.
Okay, so we've got our building blocks. Classes are the blueprints, and objects are the actual things we build from them. But how do they all work together? How do they interact? Well, that's where we get to the rules of the game, known as the 4 pillars of OOP. These are the core principles that makes the whole system so powerful. So here's our game plan. We're going to look at these 4 big ideas: inheritance, polymorphism, abstraction, and encapsulation. Don't worry about the fancy names. Together, they're what make our code organized, reusable, and way more secure. Let's break them down one by one.
First up is inheritance, and honestly, it works pretty much exactly like it sounds. It creates a parent-child relationship between classes. The child class can inherit all the properties and behaviors from the parent class. This is amazing for reusing code. I mean, why build a poodle class from scratch when you can just say it's a type of dog and it automatically gets all the basic dog stuff?
Next, we have polymorphism. Now, this is a very fancy word for a really cool and simple idea: that one single task can be done in a bunch of different ways. You can give the same command to different objects, and each one will respond in its own unique way.
Check this out. Imagine the command is speak. Well, what happens? The dog object responds with woof. The cat object says meow, and the duck object goes quack. It's the exact same instruction, speak, but you get completely different results depending on the object. That's polymorphism in a nutshell.
Our third pillar is abstraction, and this one is all about keeping things simple. Abstraction means hiding all the messy, complicated internal details and only showing the stuff you actually need to use. Think about your phone. You just tap the screen to make a call. You don't know or care about the radio signals and digital processing making it happen. All that complexity is hidden from you. That is abstraction.
And our final pillar is encapsulation. This is all about bundling an object's data, its state, and the code that works with that data, its behaviors, together into one neat, self-contained package. It's like putting a protective bubble around your data, so nothing from the outside can mess with it by accident.
The best way to think about this is literally like a medicine capsule. It keeps all the important ingredients safe and contained inside, protected from the outside world. Well, encapsulation does the exact same thing for our code. It wraps the data and the methods together to keep them safe. So, we have objects, we have classes, and we have these 4 pillars with their fancy names. But what's the big deal? Why go through all this trouble? Let's get to the payoff and see why this way of thinking is so much better than what programmers used to do.
And this picture really says it all. On the left, you've got the old way. It's kind of chaotic, right? Data is just floating around, and any part of the program can reach in and change it, which leads to all sorts of bugs. But on the right, you've got the OOP way. It's clean, it's organized, and data is safely tucked away inside its object. It's the difference between a messy junk drawer and a perfectly organized toolbox.
So what's the bottom line here? With OOP, you get something called data hiding, which just means you don't have random bits of code accidentally breaking important information. But the real game changer is what happens when projects get huge. That old, messy way, it completely falls apart. It becomes a nightmare to manage. But the organized, modular style of OOP, it's built to scale. It makes building and maintaining massive software projects actually possible.
At the end of the day, object-oriented programming is so much more than just a technique for writing code. It's a way of thinking. It's a system for managing complexity that lets us build the amazing, reliable apps and systems that we all depend on every single day. So I guess there's only one question left. Now that you understand the blueprints of the digital world, what would you build?